Hello everyone, my name is Ganesh Totla. I've been working with eTutions for quite long time now. So I've been basically teaching mathematics online on eTutions. So eTutions is an online platform where the students can connect with the tutors one on one and get their doubts clarified. So today I've chosen a topic of limits as for this video. So, everyone, you must be knowing that limits is the first step towards calculus. Calculus is a branch of mathematics which obviously deals with derivatives, integrations, indefinite, definite integrations. So, limits is the first step in calculus. Once we know limits, we will be able to understand derivatives and integrations. So, let's start with the limits. In English, in general language, in local English, limits is basically a boundary value. When we talk about limiting something, which means we are trying to control that particular quantity. The same holds good in case of calculus as well. Now, suppose we have and a function, say y is equal to f of x, where y is called as a dependent variable and x is called as an independent variable. So when we talk about independent variable, it's going to change and it is not going to change in accordance to someone. Whereas when y is called as the dependent variable, so depending upon the value of x, the value of y is going to change and hence it's called as the depending variable. So let's consider a function y is equal to f of x, where x is independent variable and y is a dependent variable. Now suppose if I have to find out the limiting value of this particular function fx. Limiting value as in it's the maximum value that particular function will achieve when x is moving some value, when x for some value of x, what can be the maximum possible value of y, that's given by the concept of limits. So in order to understand limits in further, let's check or let's learn the notation of x arrow a. This arrow, it's called as tends to, tending to, or it's also called as tends to. So when we say that x is tending to a, that means suppose if on a number line, I have a value a. Let's consider one independent variable, say x. Now this x is tending towards a, which means the x is coming nearby to a. The value of x is not a, but it is tending to a. That means the distance between x and a is becoming smaller and smaller. So when we talk about x is tending to a, this means that x is approaching a, but it's not completely a. This is a very important difference between x equal to a and x is tending to a. Now, when we talk about x is tending to A, we are not sure about the direction in which direction the x is tending towards A. Either the x is tending from left hand side, or it's tending from right hand side, or it's oscillating. It's oscillating and reaching. When we talk about x is tending to A, we are not giving the direction of x, whether it's coming from left, whether it's coming from right, or whether it's just moving or oscillating. Okay, so in order to understand the concept of limit, so we have studied what is x is tending to a. The value of x is approaching a, but it's not completely a. Consider the function, say y is equal to f of x. And now, suppose if I have to find out the limiting value of this function, so I'll write it down as limit, lim stands for limit, of this function, that is f of x, when x is tending towards a. What is the meaning of this? Like suppose if on the number line we have x a and we have a function y is equal to f of x. So when x is tending towards a, how f of x will behave, what will be the maximum value that f of x will achieve, what will be the limiting value of f of x when x is tending to a is actually given by this limit function. So I hope you have understood the meaning of the limiting value of the function, that is limits of f of x as x is tending towards a. Now, let's see some basic limits. The very first limit, what we have, some standard limits or some basic limits. Let's see some basic limits. So, limit of a constant term when x is tending to a is obviously a constant term. It's always constant because constant function is irrespective of any variables, right? So, suppose if I consider the constant function like this is independent of x, this is independent of any function, this is independent of any independent variable. So wherever at every instant of time we will be having the value fixed. That's why the limiting value of any constant function, it is always equal to the same constant, that is k. Now, next limit, suppose if I have to find out limit of x as x is tending towards a, this is always equal to this a. So when we are taking the limits, as I said, the x is approaching a, x is not a. So the maximum value what x can achieve is a. Hence, the limit is given by this sign. So limit of x as x is tending to a is equals to a. Now, this is the second important limit, basic limit. So we have seen two limits as of now. First, limit of a constant function, and the second one is limit of variable, independent variable x. When x is tending to a, it is always equals to a. Now let's see some theorems in limits. Theorems in limits are very simple. So the very first theorem is, suppose say limit of two functions f of x plus g of x. Suppose f of x and g of x, we have two functions, then limit of the addition of two functions as x is tending to a, it is equal to the addition of individual limits. So limit of f of x as x is tending towards a plus limit of g of x as x is tending to a. Same holds good with the subtractions as well. So limit of f of x minus g of x as x is tending to a is equals to limit of f of x as x is tending to a minus limit of g of x as x is tending to a. Now, limit can be also written as, instead of limit of f of x, we also can write down LT, which is again one more term that we will be using. Either you can use LIM or you can use LT. So limit of f of x as x is tending to a. You can use any of the abbreviation, whichever is easy for you and whichever is suitable for you. So we have seen two of the theorems for the limits, that is for addition and subtraction. Let's move on towards the third one. So it's about multiplication. So suppose if we have limit as x is tending towards a, f of x into g of x. Now it's about the product. So obviously we will be having limit of x tending to a of f of x into limit as x is tending to a of g of x. This is for product. Fourth theorem is about the division one, like limit of f of x upon g of x as x is tending towards a, it will be equal to the limits of the individual numerator and denominator, limits of the numerator and denominator. So this will be limit of f of x as x is tending towards a and limit of g of x as x is tending towards a again. So these are four theorems, easy theorems straight away. This will be helpful for us when we will be solving the problems on limits. Now let's see one more theorem of the limits. Like for example, if we have limit of k into f of x as x is tending towards a, so this will be just use the product rule because k into fx, where k is constant. So it will be limit of k as x is tending towards a into limit of f of x as x is tending towards a. Now, limit of a constant term, as we have already seen, it's always a constant one. It's k. So it will be k into limit of f of x as x is tending towards a. So this is basically limit of k into fx as x is tending to a. So from this formula, we come to know that the limit of a constant into function is always equal to take the constant as it is outside the limit and just take the limit of the function as x is tending towards a. So I hope some basic limits and the theorems, basic theorems and limits are understood. Now let's see a new concept called as a functional value. The name itself states that the functional value is actually the value of the function at a particular point. Like for example, if I have y is equal to x square plus 2x plus 1. So obviously my y is a function in x. X is an independent variable, y is a dependent variable. So depending upon the value of x, my y value changes. So this is my given function. And now suppose if I have to find out the f of 2. So I'm basically finding out the value of the function at the given point, that is at the given value. So in this case, what I'll do is, we know that y is equal to f of x. So in order to find out f of 2, I just have to replace x by 2 because I'm finding the functional value. So value of y at 2 will be 2 square plus 2 into bracket 2 plus 1. So wherever there is x, I have replaced x by 2. So we get 4 plus 1 and the answer is 9. So the functional value f of 2 is equal to 9. Now note, there are two important things here. First is limit, second is functional value. Or we find out the functional value at always the given point. We find the functional value at a point, whereas we find out the limiting value when x is tending towards that point. That means while finding functional value, the value of x we can straight away substitute as 2. But when finding out the limits, we don't say substitute x equal to 2. We will be saying as x is tending towards 2, the maximum possible value of that limit will be, and so on. So understood the difference here? The difference between finding out the limit and finding out the functional value. Anyhow, finding out the limits, finding out the functional values will be very important part when we will be solving the problems on continuity. So this is all about the basic of limits, some basic formula we have seen, some basic theorems we have seen. Now three more formulae, let's have a quick look on them and then we can solve the problems on limits. So the first theorem now, the first formula now is limit of x raised to n minus a raised to n divided by x minus a as x is tending towards a. This is a standard limit and this limit is always equal to, so the whatever index we have, that n multiplied by this a, this n multiplied by whatever the value of a we have given here into n minus 1. Note that if the limits are in this form, x raised to n minus a raised to n upon x minus a, this is always equals to whatever the power we have, that n, into whatever the constant we have given, a raised to n minus 1. This is very important limit for solving the problems. The another limit what we have is a trigonometric limit. Now what will be that trigonometric limit? So limit of sine x upon x as x is tending towards 0 is always 1. This is also one of the standard limit for circular functions. Circular functions means trigonometric functions. So limit of sine of x divided by x as x is tending to 0 is always 1. The next we have limit as x is tending to 0, same, of tan x upon x is also equals to 1. This is also one of the standard limit. Now, the last but not the least, very important limit, limit of 1 minus cos of x divided by x square. So whatever the theta we have here, whatever the angle we have here, that angle square will be in denominator. And this is equal to half. This is very important limit from problem solving perspective. So limit of 1 minus cos x divided by x square is equals to half. So whatever the angle x we have in here, in denominator it should be the square of that. This you have to keep it in mind. Do not keep this formula straight away like 1 minus cos x upon x square ka limit is 1. No, it will be confusing because what to take in denominator, that we don't know. So in denominator it should be the square of the angle which is associated with cos. Okay, I hope these formulae are clear. So with this we have come to the end of this demo video. In the next video, let's try solving the problems on limits. So I hope you have enjoyed my video. I've just tried to explain the concept of limits and what is the difference between taking a limit and finding out the functional value. If you want to connect with me online, then you can connect it via eTutions. So the link for the eTutions is also mentioned in the comment box. Do let me know your views on this video, and I'll stay tuned with the problems on the limits. So thank you for your time. Thank you. Bye.